Hey everyone. So recently I really started to get into the Rust programming language, and I think that's going to become really popular. So I just wanted to make a video of just highlighting some important points about Rust and what it is. I do want to note that this presentation was originally made for high school students. Uh, so there are some memes, but I think that it's really well made, so I just want to share it out to you guys. I also do want to highlight the fact that I use some examples from articles, and I did source them at the end of the last slide. So so before we begin, I just want to point out why Rust was made and the history of how it came to be, because I think it's important to recognize its history to determine why it even exists. So Rust was a personal project that basically began in 2006 by an employee called Graydon Hoare, and before that he was working with C++ in Mozilla. But the thing is, if you ever played with C++, you would know that it's kind of difficult to manage your memory. Um, Unlike if you're just an average person like me, and it's really difficult. It's just easy to make memory mistakes, just errors, and especially when you're handling concurrent code. So Graydon Hoare kind of recognized this, and he said, "Hey, let's just make a language that's specifically made for system safety." And in 2009, Mozilla began to sponsor a project. Um, and finally, in 2016, we finally got the first official release of Rust. So, like I said, Rust is a systems language. And specifically is a statically typed multi-paradigm language. And I'm going to break it down in case you don't know what that means. Statically typed means that basically you annotate your variables with a type. Um, and then multi-paradigm language means that it incorporates a lot of features or a lot of ideas from other programming languages. It is also really focused on performance, reliability, and productivity, which is one of the reasons why Stack Overflow's most loved language for 5 years. And before we even see Rust code, I do want to highlight more about systems languages. Specifically, I do want to go over what a garbage collector is and undefined behavior. Basically, garbage collector is a feature in many programming languages like Java or Python that automatically frees memory that is not used in runtime. And undefined behavior is basically what it's self-explanatory, but it's basically when a program runs unexpectedly. When you as a programmer are writing some code and doesn't really work out the way you expected. I also do want to highlight the fact that, in case you don't know, there are two different kinds of memory in a computer, which is the stack and the heap. And you can think of like an easy way to think of it is like the stack should just carry um, values primitives like ints, doubles, or chars, and from Java. And the heap should carry mostly more abstract ideas like arrays and objects. This way, we can keep on using them even when it's their scope goes out of balance. So let's just start looking at some Rust just basics. Um, as you can see here, there's some types here. I don't want to really cover them, but I do want to highlight one of them, which is a char. And I do want to highlight this because, as you can see, as you can see here, I wrote that it uses UTF-8, which means that it uses 4 bytes for every char. And this is very important to highlight because in other systems languages, if you're familiar with like C or C++, you basically just get like some ASCII notation, or enough for an ASCII character. And this is because Rust really wants to handle everything, including strings. So because of this, we can get some like out of the box support with Rust. So you can see we can write, I guess, Unicode or UTF-8 characters, and it's all valid in Rust. And this is basically an example of how you write variables in Rust. It's also nice to say, but basically, I did say that Rust was a statically typed language, but in most cases, it can actually guess the type of what your variable is, or yeah. And but you could also kind of notate it, like I said. In case you don't know, Rust has tuples and also has arrays that are with known sizes at compile times. And if you're from Java, it also has like an array list, but they are known more as vectors. And let's just start getting into like more complex things. Those are just kind of guess primitives that you need to know, and these are more functions. So as you can see here, this is how we write a function name, a function, and the parameters, and then the type. But I do want to highlight, I guess, the switch case, or what other languages might know in switch case, or in this case, a match case. And this was one of the like, features where Rust comes in. It's very I guess, helpful. And it's expression matching. As you can see here, we just write 0 and 1 to return like the first Fibonacci numbers, but then we have like this underscore, and this is supposed to like I guess match whatever n is if it's not 0 and 1, and then we'll just return this. I think this is very powerful, and it just like matches your expression, so you don't really have to keep on writing down or handle other cases. And with this, you can just make sure that your program, if you don't really know what's going to happen, you can just say in the match case, hey, there might be an error, and we can just, and with this match case, you can handle it. And here's another implementation a simple implementation of FitzBuzz. And if you don't know what FitzBuzz is, basically it takes the number 0 to 100 or 1 to 100, and if a number is a multiple of 15, 5, or 3, it will print out some special characters, or else it would just print out the number. And I just wanted to highlight here that we can just like assign this result variable to a loop, or an if else chain, and whatever it results, we're just gonna automatically assign it to result. And it's part of just this expression Rust has, and I think it's really it's a really helpful feature. Finally, I just wanted to highlight some more complex, ideas in, or not complex, but more, I guess, if you're more familiar with object-oriented programming, Rust kind of has that too. It's not really an object-oriented programming language, but there are some ideas you can use it to, stimulate that idea. So we have here structs. In structs, you can think of structs like classes, where they have like variable type, variable name, and then their type. You can see here we're making a card struct with some fields. And then we have some enums, and enums are really powerful in Rust. I suggest you use them when possible. And the reason for this, as I said, Rust is really a language made for systems safety. So one of the special things about enums is that it prevents data entry errors. So in case you ever make an enum field type, and then you don't assign it to one of these, field types, then it will the compiler will complain, and it will tell you, hey, you need to make sure that it's one of these types, or one of these data fields. Finally, you also have, methods for, the structs. And as you can see here, we use the keyword implement, and then we just implement whatever methods or functions we want for our struct. And if you're familiar with Java or Python, we have like this. We can create like this new constructor for a struct, and we can just assign whatever fields we want to it, or parameters we want to it. And the last thing I wanted to note is traits. And you can think of traits as something like Java's interfaces or C declaration headers, but it's more familiar to like Java's interfaces because it gives the ability to use polymorphism. And as you can see here, we're just like making some function signatures or method signatures, and we're gonna just like assign the the type we're going to get in return. And then later on, when we want to implement the trait for whatever struct we are, we can actually implement these functions for the struct car. And traits are really powerful because, polymorphism, you can just make a trait and then have a struct implement whatever that trait is, and you can just get different behaviors for different structs with the same, I guess, a trait. So now that we just had some basic building blocks of Rust, we can finally start just emphasizing more points and just get into the more complex or the fun features, which I think are important to highlight. So, as I said, writing good code is hard, but writing safe code is harder. You want to make sure that whoever's using your code or whoever's running your program is going to get the result you want exactly. And that is why you need to handle a lot of cases, which means that your safe code has to be almost perfect. And finally, working with memory, it's even dangerous because you might get some unexpected errors. So I think in order for us to understand why Rust is so powerful, we kind of need to look at C. And this is basically a very bad implementation of vectors or a dynamic array in C. And this, I guess, just a code block has a lot of errors. Here, and I'm just going to go over some errors this example has. For example, here we have this function called vecNew, and it's supposed to represent a constructor, but this constructor is stack allocated. We never allocated to a heap, which means that basically when this function ends, we're gonna get nothing. We're just gonna get a pointer that is not that does not point to the data we want, and that is obviously an issue since we want to use this vector in other functions. Finally, we also have the fact that we assign the field capacity to 0, which means that whenever we try to I guess allocate more memory for this vector to hold more values, we are going to get an error. And specifically right here, whenever we multiply by 2, it's always going to equal 0. And that is not good. We're just going to get some unexpected behavior right there. We also have this vec-free function, which incorrectly, I guess, orders around the freeze. Obviously, we free the vector here, but then we try to look into the data field of the vector, but that's not going to exist because we already freed the vector. So as you can see here, this might be an example some person who is new to C might come up with too, but it's going to obviously have a lot of I guess errors. And this is where Rust kind of comes into. Rust sees this and sees, hey, this is actually really hard. Programmers should be dealing with implementing more or implementing higher programs. We shouldn't really be dealing with taking care of just making sure we're not going to get an error with our implementation. So, as I said, Rust and memory safety. Those are the two things you really want to highlight. And basically, Rust is a language that you can that allows you to check for errors before runtime. And this means that basically, if you get a Rust program to compile, you can be basically 100% sure that it's going to run the way you want it or the way you wrote it. That doesn't mean that's necessarily going to be the answer you want, but as a programmer, it's going to be how you wrote your code exactly. Which means that one of the features that it has is that everything is immutable by default, And if you don't know what immutable means, is that basically you really can't change the data of a variable by default. And as such, we are kind of forced to handle errors when we write our code. And there's the fact that, and the way that this kind of works is by two features in Rust called ownership and borrow checking. Finally, there's this pi I really just want to highlight because I said there's a lot of errors in a lot of languages. So this is, I guess, the Linux kernel's just overview and what kind of bugs it gets. So as you can see here, like most of the bugs here are actually memory related, and this is not that great because, as I said, we don't really want to be able to. We want to just implement more features for the Linux kernel, but when we get errors like this, we don't know how that's going to affect our code base. So let's get started. So two of the main features I said is ownership and borrow checking. And basically, ownership is it's the idea that Rust implemented where every variable has a thing called an owner. And there can only be one owner at the same time, but multiple references. We're going to get into that later. And basically, when the value or the owner goes out of scope, the value will be dropped. Which means that basically, whenever a variable just goes out of, like when a while loop is done, we're going to automatically free that data due to this ownership system. And the ownership system kind of works with the borrow checker system. And there are just more specifications that says we really can't use, you really can't move the value of a variable twice because that will go against the ownership system. And these two kind of work really tightly together to make sure that you can only use a variable or you can really change a variable's data once. So you can imagine by using this system, we can get rid of data races. And if, in case you don't know what a data race is, basically when two concurrent threads or try to change the same, value twice. But if it changes the same value twice, you're gonna get some. At the same time, you're gonna get some errors right there. So this is an example of just what the ownership system might look like. Where we're assigning a global struct A, and then we're gonna assign it to this variable A. But after using A, we're also gonna assign it B. So that means that B now owns, struct A. But we're also assigning it to the variable C to A. But the thing is, the Rust compiler is going to scream at us. It's going to tell us this is no good because this goes against the ownership system we have here. And exactly tells us here, move occurs A because it has type A, and then we move the value here, which means that B now owns A. But it also tells us, hey, we have about A doesn't have anything because B now owns struct A, so it's obviously gonna error out. And you might think that this is annoying at first, and I guess the example I gave is not the greatest, but as you can imagine with my data erase example, Rust will make sure that you are only going to change the value of a variable once. And I think that when you're writing, drivers, this might be very beneficial because you know that everything you're going to end up writing is correct. So let's move on. As I said, Rust is very keen on error handling, and which means that it has some special, syntax sugar to deal with errors. So this is an example of just me creating an image, like a graphic image, a PPM image in Rust. And we can see here that we're trying to write to a file. And we're trying to just write some thing to a file, but we here have a question mark. And basically, whenever you write to a file, you might think of any well, there might be some errors that you can have when you're trying to write to a file, such as the file is already being written in, or the file doesn't exist. And by using this question mark, you're telling Rust that you already know and you're going to handle it. And here, as you can see here, we're also using unwrap here because sometimes you might not have permission to create files, but by using unwrap, we're basically telling Rust, yeah, we know there might be errors, but we're going to handle it. Again, as you can see here, and we just have like these functions, or I guess syntax triggers, just to handle these errors. And we're gonna, whenever you write a program in Rust, we have to be mindful that there might be errors, but as a programmer, we know that we're gonna handle it. And that's the main thing I want you guys to take on. And finally, there's also the fact that Rust has zero cost abstractions. Not everything is zero cost, but most of the things are. But basically, what zero cost abstractions basically means is that whenever we have like very complex things, like like calling another function, or in a function, Rust is basically gonna optimize those calls, and it's gonna allow us to have cool features, but not at the expense of, I guess, speed. So these are just three examples I gathered just to show how this kind of works. So this is a simple implementation where we're just basically taking any number 1 to n, and then we're summing them together. And this is something you can really write in any language. And when we kind of see the output of what the assembly looks like, we can see that it's very simple. It's not complex. Like we're compiling this to this assembly, and there's really not that many loops, or there isn't any loops. But like I said, this is generic. This is something you might write in any programming language, but it's not really Rust. It's not really with the Rust, not the Rust way. So these are two Rust, I guess, two examples of the same function written in the Rust way. And here, I'm not going to explain what this means, but we basically, as you can see here, we're creating this. We're using a lot of Rust methods to be able to do the same thing, and it's certainly, I guess, more complex, more abstractions. But the thing is, whenever, sorry, let me get into it. The thing is, whenever we if we also use the same thing, and then we compile it to assembly as well, we can see that even though we're using more abstract methods, or like more abstractions that are provided by Rust, it's going to compile to the same assembly. And the same thing goes with the third example. So the point is that even if we have like really cool features with really cool features and more complex abstractions, Rust is going to take care of that, and it's going to optimize it the way we'd expect it. So our code, it's going to run just as fast as something like C sometimes. Finally, I do want to highlight that Rust has really cool macros. And if you don't know what macros are, they basically are part of metaprogramming, and that basically says that it's basically code that writes other code. And the cool thing about macros in Rust is that there really isn't runtime. There isn't a runtime cost. So whenever you make like a macro, it's gonna just gonna apply to your binary size, and that means that you are not gonna have like any I guess downsides whenever you're running your program. So there are two types of macros in Rust. There are declarative and procedural. Well, there isn't actually any types, but these are just kind of the ideas we have currently. Um, and in the future, I think the Rust team is trying to just make them more, to make them into, like, I guess, one type. But for now, we do have two types. And so let's just take a look at declarative. And declarative, you use basically the syntax macro rules, and then define your macro. So for example, we're defining this add as, and then so in Rust, I'm sorry I didn't explain this before, but in Rust, you whenever you use macro, you're always going to see this exclamation mark, which represents that this thing is a macro. So here we're gonna saying that we're using this macro as, and we're providing these parameters to this macro, and basically we're, like I said, this is gonna compile to other code. This macro is gonna write other code. So basically, the parameters we have here are gonna be substituted to this, to right here, and it's gonna just add them together, like as the function says. And this might not be a good example, but as you can see here, you can create a lot of cool stuff just by using macros. For example, the Rust team uses the vec macro to automatically create a new vector, and then push all the elements you want into this vector, and then finally it will return the vector. So as you can see here, instead of like writing this whole creating like this like a vector yourself and then making it like a while loop or a for loop of how many elements you want, this is just automatically going to run, and it's efficient. There's also procedural macros, and procedural macros are kind of a bit different because they are applied to a struct, or they are applied to as like attributes. So in Rust we have these things called attributes, and they kind of manipulate whatever is below them. So in this case, we are using the attribute derived getters, and it's going to manipulate this struct called newsfeed. And basically, it can just create getters for all the fields in this struct, and it will just do it to when it compiles, we will actually be getting this result. Sorry, and then these are just derived macros. And you can see like there's a lot of I know that a lot of libraries use these attributes or these procedural macros to create more complex things. Like I know that one library calls a macro to basically serialize your data to a different language to use. And basically, this is a really nice way for you as a programmer to just call it and just not have to worry about implementing this, because you know that the macro is going to do it itself. Finally, I do want to highlight the point that compiler messages are amazing in Rust. It's one of the best things in Rust, because even though there are going to be like a lot of things for you to handle, the Rust developers know that, and one of the ways they made it, they made Rust better by having amazing compiler messages. So as you can see here, we just have this struct color, and it has RGB, something you would expect for a pixel. But whenever we're constructing this new struct, we made a mistake here. Instead of B, we wrote D. And when we compile it and run this code, you see that the compiler is going to tell us, hey, there's actually a field, you actually made an error here. It doesn't really exist, but there's a similar field called B. You might want to check that out. And exactly as you can see here, it's very helpful because it's basically just telling you what error you made and how to fix it. And then you can see here we also have the ability to just learn more about the error. And the more you use Rust, the more you're going to appreciate this. That it's just going to give you a lot of suggestions on how to fix your code. I would say the Rust compiler is more as a teacher you should work with because it's teaching you how to how to make your code better. Finally, I want to go over the fact that the Rust toolchain is pretty amazing. Basically, there's one tool a lot of people use, and that is Cargo. I think most people actually use it. I might be wrong about that. No, I'm pretty sure like 100% use it. But again, I'm sorry, I might be wrong about that. And basically, Cargo is your build system, which means it's gonna build your project, but it can also do a lot of more things. For example, if you ever worked with JavaScript, you know that there's a thing called Node and npm. Yeah, and npm is used more for, I guess, uploading and then downloading more, I guess, libraries you want to install. And by using Cargo, and then in Cargo, in this case, we are using the same thing to build our system, but also upload and install crates. And if you don't know what crates are, I don't think I mentioned this, but crates are just Rust terms for libraries. There's also the fact that Cargo, it can be used for unit tests. So if you work with Python, you know there's a thing called PyTest, but it's also like a different thing you have to install. But with Cargo, we can automatically just use the same thing to test our programs. There's also the fact that we can benchmark our code, and I think a really good thing is create documentation. So So in Rust, we have two types of comments. There's the comment where we just do. Let me just try an example here, where we just use two forward slashes, and this is something you would normally see in a lot of programming languages. But if we add a third slash, that is basically gonna indicate that this is a documentation comment. And basically, whenever we generate documentation with these and then add some documentation comments to our code, Cargo is automatically going to parse for those, and it's going to create a like an HTML document that you can just upload to the web. And basically, you're going to end up with a system that your code is self-documenting, and it's just very nice because you know that if someone writes a library, you can at least see their API at a superficial level, at the very minimum. Cargo also has Clipper, and it's basically a better linter because it's gonna give you more suggestions, and it's gonna tell you like, hey, there might be some things you can do here that's actually better, and it's gonna optimize your code. Finally, we have like Rust Up. Rust Up is the program you use to install Rust and other components. There's also a Rust formatter. And all these things you can just install by using Rust Up. And then Rust Up and Rust formatter is just basically it formats your code automatically. So you don't really have to use a code, like you don't have to, like if you're using JavaScript, you know that there's a lot of tools you can use to format your code like this way. And I know that Python has a lot of like formatters, but with just like having its own supplied tool chain, Rust can make sure that everyone's running the same tools, unlike other languages. The final thing I want to highlight is the Rust Analyzer, which is a very amazing language server. And this is a language server. It's just a thing that basically gives you your autocomplete or IntelliSense and snippets, and it's very amazing because it helps you so much. And I recommend using it over something called RLS if you aren't not using it. And so yeah, overall, very great tool chain for us. Finally, the last thing I actually want to highlight is its libraries. There's a lot of high performance libraries out there in Rust. And when you use like Rust, you can like I guess when you use these libraries that are made for Rust, you can be like kind of sure that these languages, like these libraries, are highly performant and very well written. One of the things I want to mention is the regex library, the regular expression library, because it's one of the best regular expression libraries in any programming language. And here's a code snippet where I used it. I just use the regex library, which and for if you don't know, Advent of Code is just this really cool, I guess, Christmas thing where a tournament kind of competitive programming kind of thing, where you just solve problems for puzzles they give out, and I use Rust for that whole contest. And basically, we just create this, I guess, the regular expression we want, and then we can just even through this we can just I guess create the capture groups we want and then use them the way we want them. And I wanted to point out that the Rust regex library was used to make this tool called ripgrep, which is a very great tool, and I would suggest for people to look it up in case you don't use it already, because it's basically I think a better grep. In some cases it's more it's faster than grep. And these are other libraries. I won't mention them because I don't really want to explain what they are or what they do, but they are great. Like one of the things I do want to highlight is the WASM which integration with WebAssembly, and it's really popular right now. So, and Rust has one of the best integration with WebAssembly, so I just wanted to highlight that. And yeah, it's just great libraries overall. So we're ending the end of presentation, and so like I said a lot, I spoke a lot, and I gave like some overview. But what can you actually use Rust for? Obviously, you can use it for writing system software, like drivers, like operating systems. I know there's an operating system actively being, I guess, made in Rust called Redux, I think. Sorry if I don't know that one. There are a lot of web projects like Dropbox, Discord that use Rust as at least one of their components. They use Rust to write one of their components. They're especially. Also, due to the lack of garbage collector in Rust, so I think I mentioned this, but Rust doesn't have a garbage collector. You have to, I guess, deal with it yourself. I guess it's optimal for game use, because some things like, for example, like the game Minecraft, it's written in Java, but sometimes you're gonna get a bit of lag, and the reason because you get those lag spikes is because basically Java is trying to get rid of objects you don't need in your game, and since the garbage collector is running in the background, you're not gonna like your game's not gonna perform as well as not having in the background. But because Rust is a non-garbage collector language, it doesn't really have that downside. And as you can see, that if something for like an FPS, you might really want that. So also networking, it's very huge. Like if you're making a web server, if you have to make a lot of transactions, Rust, you need to make sure that's secure and reliable, and Rust is the perfect language for that. Machine learning, I did write this down, and there are some things down, but I guess this is clickbait because it's not there yet. But it's also, it's really, but they will be at one point there, because basically there's a lot of performance, and it's kind of great for like the machine learning, I guess, the implementation part. Finally, why shouldn't you use Rust? Like, I've been talking a lot about Rust and what it is, but there are some downsides, of course, and I need to highlight this because I think it's fair for a person to know what these downsides are before they actually use Rust for a project. And basically, due to like the many features Rust has, the compiler is a tad slow. I'm not gonna lie. It's very slow compared to like something like GCC. Well, not that slow compared. Well, not like it's usable, but it's still very slow. And the fact that Rust is very slow, very new. It was made the first official release was in 2015. We're in 2021, and it's only been 6 years. Companies are just starting to adapt this language more and more, but it's still overall new, and that's kind of a concern because like some of the APIs might change, or especially in libraries, like new libraries. And also the fact that we don't really have like every language, every library written for it. Like Java has like so many libraries you can use, and Rust is still not at that point. I believe. There's also the fact that the language is kind of difficult for people coming from more high level languages like Python. It's a systems language, of course, but the fact that you have to deal with ownership, you have to deal with like all these new concepts, it's kind of difficult. And also Rust is I guess, a lot harder to learn than C or C++ initially, due to the fact that you're just gonna have to like look at the documentation for what ownership and like the compiler messages. And whereas in C and C++, you can just like basically look up a tutorial, run like I guess very simple program, program on your like first day. I feel like in Rust, you're probably gonna have to look at the documentation for your first day, and that makes it, I guess, harder to learn. So that's it. And uh, there are some resources I just wanted to point out. Uh, this repo, like this whole presentation is basically a markdown file. So if you just ever want to look at it, you can do so. These are a lot of more resources. Finally, I know that people want to be hired, so there are, like as I said, companies are starting to adapt, and more companies are looking at Rust. I know that Amazon has their own Rust team, especially just for like working with Rust. So I guess that's kind of cool. And as I said, I do have some sources. And if you want to know how I made this presentation, I use this program called Look at Me. It's very nice and I recommend it. So anyway, thank you for watching, and bye.